everyone, I'm Norhana Iftinan from Malaysia, and the capstone project I will be presenting today is called CAPASH, which stands for Carbon Capture Using Palm Oil Ash. Let's start with story of self. My journey into being an active global citizen started during the 2021 floods in Hulu Langat, Malaysia. I was just 11 years old when I volunteered to help clean houses and distribute food to families who had lost almost everything. Seeing the effects of climate change using my own eyes changed something in me. It was no longer just about interest, it became personal. I felt determined to make a change, to become a change maker. Moreover, I joined several science competitions throughout the 3 years I'm in high school, like Mayo, Science Castle, and STEM Racing. Being part of those events made me realize that science wasn't just about formulas, it's a tool to solve real-world problems. My idea initially derived from when I started to notice just how much palm oil waste were produced in Malaysia when I was on my way to my village, especially the ash from burning the waste. I spoke to my mom about it and she encouraged me to look deeper, and that's where I discovered research from a university in Singapore where they turn incineration ash into a material that can capture carbon dioxide. That inspired my idea. What if palm oil ash could do the same? What if I can tackle two problems with just one solution? And that's where my most important sentence came from. Moving on to story on us. Palm oil is a major industry in Malaysia. Though it brings a higher profit for Malaysian economy state, it also generates millions of tons of waste, one being the ash from burning the empty food bunches and biomass after the oil is produced. That ash often just gets dumped back into the plantation farm, causes unnecessary and inefficient waste management. At the same time, statistics shows that Malaysia's temperature is rising at a rate of about 0.14 Celsius to 0.25 Celsius per decade. It might sound small, but it adds up and it affects agriculture, air quality, and public health. Research shows that 2024 has the highest rate of CO2 emission throughout this century and will keep going higher and higher. Other than that, I also interviewed communities living near these areas, and they told me about the dirty air from the debris and small particles and health concerns that they face every day. Additionally, communities around me, such as students in my school, also complain about how hot Malaysia is getting. Considering Malaysia has no four seasons, it's hot and humid all year around, and it's getting hotter and hotter. Now, while carbon capture technology do exist, it's usually expensive and designed for large-scale industrial use. It's not something that everyday communities can use. And that's where CAPASH comes in, a low-cost, community-focused solution using a waste product we already have and forgotten and set aside. Next, here are my problem statements that further support my research for my project. At last comes the story of now. First, my project supports 4 Sustainable Development Goals. Here are the goals. Second, here's an initial visual sketch about my prototype and how it works. First, palm oil ash contains compounds like calcium oxide, silica, and potassium oxide. These compounds can react with carbon dioxide to form stable carbonates, especially when exposed to high temperature. Third, comes the progress of making my prototype. I first warmed the ash to kickstart the reaction. I used a balloon experiment where I mixed vinegar and baking soda to produce CO2 in the balloon. Then I direct the balloon into the warm ash to capture CO2 and observe the changes. While the reaction is slower at lower temperature, it will start forming carbonates compound that looks like small rocks that trap CO2 permanently. Hence, the carbonated compounds are not reactive and are safe to use. Now, the final product, that is the carbonated compound, or as I call it, carbonated rocks, can be mixed with cement and used in construction, make it more eco-friendly and then normal cement. It also can be used for decorating paving pathway or landfill-based material, adding an aesthetically pleasing hint to it. It is a sustainable and practical use of waste. After that, some experts that I consulted mentioned that burning the ash at a high temperature, like incinerators that operate above 500 degrees Celsius, can make the process much more effective and would speed up the process and improve the carbon capture potential. While the early results are not yet as effective, it is promising. CAPASH is still growing, but it's built on a simple idea. Use what we already have to protect the future we want. I hope that my capstone project can help my community and the world one day. With this opportunity, I would like to thank everyone that has helped me, the AFS team, my mentors and facilitators throughout the virtual program, my science teacher, and most importantly, my family that never failed to support me ever since day one. That is all from me. #Let's all be changemaker together for the better. Thank you, everyone.